This is The Hidden Life of Trees by Peter Wolbe. We're in chapter 19. Yours or mine? The forest ecosystem is held in a delicate balance. Every being has its niche, its function, which contributes to the well-being of the all. Nature is often described like that, or something along those lines. However, that is unfortunately false. For out there under the trees, the law of the jungle rules. Every species wants to survive, and each takes from the others what it needs. All are basically ruthless, and the only reason everything doesn't collapse is because there are safeguards against those who demand more than their due. And one final limitation is an organism's own genetics. An organism that is too greedy and takes too much without giving anything in return destroys what it needs for life and dies out. Most species, therefore, have developed innate behaviors that protect the forest from over-exploitation. We are already familiar with a good example, and that is the jay that eats acorns and beech nuts, but buries a multitude of them as it does so, ensuring that the trees can multiply more efficiently with it than without it. Whenever you walk through a tall, dark forest, you are walking down the aisles of a huge grocery store. It is filled with all sorts of delicacies, at least as far as animals, fungi, and bacteria are concerned. A single tree contains millions of calories in the form of sugar, cellulose, lignin, and other carbohydrates. It also contains water and valuable minerals. Did I say a grocery store? A better description would be a heavily guarded warehouse, for there is no question here of just helping yourself. The door is barred, the bark thick, and you must come up with a plan to get to the sweet treasures inside. And you are a woodpecker. Thanks to a unique structure that allows its beak to flex and head muscles that absorb impact, a woodpecker can hack away at trees without getting a headache. In the spring, when water is shooting up through the trees, streaming up the buds, and delivering delicious provisions, several species of woodpeckers called sapsuckers drill dotted lines in small holes in the inner trunks or branches. The trees begin to bleed out of these wounds. Tree blood doesn't look very dramatic. It looks a lot like water. However, the loss of this bodily fluid is as detrimental to the trees as it is to us. This fluid is what these sap-sucking woodpeckers are after, and they begin to lick it up. The trees usually mostly tolerate the damage, as long as the woodpeckers don't get carried away and make too many of these holes. Eventually, the holes heal over, leaving patterns that look like intentionally decorative scarring. Aphids, sometimes called plant lice or green flies, are much lazier than woodpeckers. Instead of flying about industriously and hacking holes here and there, they attach their sucking mouthparts to the veins of leaves and needles. Thus positioned, they get royally drunk in a way no other animals can, The tree's lifeblood rushes right through these tiny insects and comes out of the other end in large droplets. Aphids need to saturate themselves like this because the sap contains very little protein, a nutrient they need for growth and reproduction. They filter the fluid for the protein they crave and expel most of the carbohydrates, above all, sugar, untouched. Little wonder it rains sticky honeydew under trees infested with aphids. Perhaps you've had the experience of parking your car under a stricken maple, only to come back to the thoroughly filthy windscreen. There are specialized sap-sucking pests for every tree. Firs have the balsam twig aphid, spruce, green spruce aphid, oaks, oak leaf phylloxera, and beeches, woolly beech aphid. There's sucking and excreting going on everywhere. And because the ecological niche of the leaves is already occupied, there are more species painstakingly boring their way through thick bark to reach the places where sap is flowing underneath. Pests that attack bark, such as woolly beech scale, can completely envelop trunks with their waxy, silvery white wool. These irritants have a similar effect on a tree as scabies has on us. Festering wounds appear that take a long time to heal and leave behind rough and scabby bark. Sometimes fungi and bacteria get in and weaken the tree as well, so much so that it dies. It's no surprise that trees try to defend themselves against these scourges by producing defensive compounds. If the infestations continue, it helps if trees form a thick layer of outer bark to finally get rid of the sap-sucking pests. If they do that, they are protected against further attacks for at least a few years. The possibility of infestation is not the only problem. With their voracious appetites, sap-sucking pests remove a gigantic quantity of nutrients from trees. Per square yard of forest, the tiny pests can tap many hundreds of tons of pure sugar from the trees. Sugar the trees can no longer use to grow or set aside in reserve for the coming year. For many animals, however, sap-sucking pests such as aphids are a blessing. First, they benefit other insects such as ladybugs, whose larvae happily devour one aphid after another. Then there are forest ants, which love the honeydew the aphids excrete so much that they slurp it right up from the aphids' backsides. To speed up the process, the ants stroke the aphids with their antennae, stimulating them to excrete the honeydew. And to prevent other opportunists from entertaining the idea of eating the ants' valuable aphid colonies, the ants protect them. There's a regular little livestock operation going on up there in the forest canopy, and whatever the ants can't use doesn't go to waste. Fungi and bacteria quickly colonize the sticky coating that covers the vegetation around the infested trees, and it soon gets covered with black mold. Honeybees also take advantage of aphid excretions. They suck up the sweet droplets, carry them back to their hives, regurgitate them, and turn them into dark forest honey. It is particularly prized by consumers, even though it has absolutely nothing to do with flowers. Gall midges and wasps are a bit more subtle. Instead of piercing leaves, they reprogram them. To do this, the adults lay their eggs in a beech or oak leaf. The sap-sucking larvae begin to feed. and thanks to chemical compounds in their saliva, the leaf begins to grow into a protective casting or gall. Leaf galls can be pointed or spherical, but in both cases, the young insects inside are protected from predators and can nibble away in peace. When fall comes, the leaf galls fall to the ground together with their occupants, which pupate and then hatch in spring. Particularly in beech trees, there can be massive infestations, but they do very little damage to the tree. Caterpillars are a different story. What they set their sights on is not sugary sap, but leaves and needles in their entirety. If there aren't too many of them, the tree barely notices, but populations explode in regular cycles. I had a run-in with one of these population explosions a few years ago in a stand of oaks in the forest I manage. The trees cover a steep south-facing mountain slope. That June, I noticed with horror that the fresh new leaves had completely disappeared, and the trees standing in front of me were as bare as if it were winter. When I got out of my Jeep, I heard a loud roaring like the pounding of rain in a storm. But there was a clear blue sky above me, so the noise couldn't be because of the weather. No, it was a hail of feces from millions of oak leaf roller caterpillars. Thousands of black pellets were bouncing off of my head and shoulders. Ugh! You can see something similar every year in large pine forests of eastern and northern Germany. Commercial forest monocultures also encourage the mass reproduction of butterflies and moths, such as nun moths and pine loopers. What usually happens is that viral illnesses crop up towards the end of the cycle and populations crash. The caterpillar pellets end in June, when the trees are completely stripped of their leaves. And now, the trees have to muster their last reserves to leaf out again. Usually, that works just fine. After a few weeks have passed, almost no signs of the feeding frenzy remain. However, tree growth is limited, which you can see in the particularly narrow growth ring in the trunk for that year. If trees are infested and defoliated for 2 or 3 years in a row, many of them will weaken and die. Conifer sawflies join the butterfly larvae in the pines. Sawflies saw open plant tissue so they can lay their eggs there. It's not the appetites of the adults, but the larvae that the trees have to worry about. Up to 12 needles a day disappear into each tiny mouth, which quickly gets dangerous for that tree. I've already explained in Chapter 2 the language of trees, how trees use scent to summon parasitic wasps and other predators to rid themselves of pests. However, there is yet another strategy they can employ, as demonstrated by the bird cherry. Their leaves contain nectar glands, which secrete the same sweet juice as the flowers. In this case, the nectar is for the ants, which spend most of the summer in the trees. And just like people, from time to time, these insects crave something heartier than a sugary snack. They get this in the form of caterpillars, and thus they rid the bird cherry of its uninvited guests. But it doesn't always turn out the way the tree intended. The caterpillars get eaten, but apparently, sometimes the amount of sweet nectar the tree provides doesn't satisfy the ants, and they begin to farm aphids. As I've explained, these creatures tap into the leaves, and when the ants stroke the aphids with their antennae, they exude droplets of sugary liquid for them. The feared bark beetle basically goes for broke, seeking out weakened trees and trying to move in. Bark beetles live by the principle all or nothing. Either a single beetle mounts a successful attack and then sends out a scented invitation for hundreds of his kin to come on over, and they kill the tree, or the tree kills the first beetle that bores into it, and the buffet is canceled for everyone. The coveted prize is the cambium, the actively growing layer between the bark and the wood. This is where the tree trunk grows. This is where the trunk grows as wood cells form on the inside and bark cells form on the outside. The cambium is succulent and stuffed full of sugar and minerals. In case of emergency, people can eat it also. You can try this out for yourself in the spring. If you come across a spruce recently downed by the wind, cut off the bark with a pocket knife. Then run the blade flat along the exposed trunk and peel off long strips about 1/3 of an inch wide. Cambium tastes like slightly resinous carrots and is very nutritious. Bark beetles also find it nutritious. That's why they drill tunnels into the bark so that they can lay their eggs close to this energy source. Well protected from enemies, the larvae can eat here until they are nice and fat. Healthy spruce defend themselves with terpenes and phenols, which can kill the beetles. If that doesn't work, they dribble out sticky resin to trap them. But researchers in Sweden have discovered that the beetles have been arming themselves. Yet again, the weapons are fungi. These fungi are found on the beetles' bodies. As the beetles make their tunnels, the fungi come along for the ride and end up under the bark. Here, they disarm the spruce's chemical defenses by breaking them down into harmless substances. Because the fungi grow faster than the beetles drill, once they make it under the bark, they are always one step ahead. This means all the terrain the bark beetles encounter has been decontaminated and they can feed safely. Now, there is nothing to stop a population explosion, and the hundreds of larvae that hatch eventually weaken even healthy trees. Not many spruce can survive such massive attacks. Large herbivores show less finesse when they need to eat many pounds of food daily, but deep in the forest, food is hard to find. Because there's hardly any light, there isn't much greenery on the forest floor, and the juicy leaves high up in the crown are out of reach. So, in the natural course of things, there aren't many deer in this ecosystem. They get their chance when an old tree falls over. After the fall, light reaches the forest floor for a few years, and not only young trees grow, but also for a short period of time at least, wildflowers and grasses. Animals rush to this oasis of green, which means that any new growth is heavily browsed. Light means sugar, which makes the young trees attractive to browsers. In the dim light beneath the mother trees, their tiny meager buds usually get hardly any food. What little food they need to survive as they wait for their turn to grow, they get from their parents, who pump it to them via their roots. The sugar-deprived buds are tough and bitter, so the deer pass them by. But as soon as the sun reaches the delicate little trees, they start budding out like mad. Photosynthesis gets underway. The leaves get thicker and juicier, and the buds, which form over the summer to break out next spring, are all over the youngsters, and full of nutrients. And that's the way it should be, because the next generation of trees wants to step out on it and grow upward as quickly as it can before the window of light closes again. But all this activity attracts the deer's attention, and they don't want to miss out on the delicacies on offer. And now the competition between the young trees and the deer heats up for a few years. Will the little beeches, oaks, and firs manage to grow tall enough, fast enough, so that the animals can no longer get their mouths around all the important main shoots? Usually, the deer don't destroy all the little trees in one small group, so there are always a couple that escape damage and battle on upward. Those whose leading shoots have been nibbled off now grow bold and bent, and they are soon overtaken by undamaged shoots. Eventually, damaged youngsters will die from light deprivation and return to humus. One rascal that does more damage than it looks as though it should from its size is the honey fungus mushroom, that innocuous-looking fruiting body that often appears on tree stumps in the fall. They are found in both Europe and North America. None of the 7 honey fungus mushrooms native to Central Europe do trees any good. Quite the opposite, in fact. Their mycelium, white underground threads, force their way into the roots of firs, beeches, oaks, and other species of tree. Eventually, they grow up under the bark, where they form white, fan-shaped patterns. The bounty they steal at first, mostly sugar and nutrients out of the cambium, is carted off in what looks like thick black cords. These root-like structures, which are sometimes referred to as bootlaces because of their appearance, are unique in the world of fungi. But honey fungus doesn't content itself with sugary treats. As it continues to develop, it eats through wood as well and causes its host tree to rot. At the end of the process, the tree eventually dies. Pine sap, which belongs to the same family as blueberries and heathers, is much more subtle. It doesn't contain any green pigment. It manages to grow only a nondescript light brown flower. A plant that isn't green doesn't contain any chlorophyll and therefore cannot photosynthesize. This means the pine sap depends on others for food. It insinuates itself with mycorrhizal fungi, the ones helping the trees root. And because it doesn't photosynthesize and therefore doesn't need any light, it can grow in even the darkest stands of spruce. There, it taps into the flow of nutrients traveling between the fungi and the tree roots, siphoning off a portion for itself. Small cow wheat does something similar, only rather more sanctimoniously. It also loves spruce and also hooks up the root fungi system, joining the feast as an uninvited guest. Although its above ground parts are typical plant green and can indeed turn a bit of light and carbon dioxide into sugar, they are mostly a display to disguise what's really going on. Trees offer considerably more than just food. Animals abuse young trees by using them as convenient rubbing posts. For instance, every year, male deer have to get rid of the skin or velvet from their soon-to-be shed antlers. So they search out a little tree that is sturdy enough to not break easily and at the same time also slightly flexible. Here, the lords of creation let loose for days on end until the last scrap of itchy skin has been rubbed off. The little tree's bark is in such a bad state after this performance that the tree usually dies. When they are choosing their trees, deer go for whatever is unusual. Whether they choose spruce, beech, pine, or oak, they will always choose whatever is uncommon locally. Who knows? Perhaps the smell of the shredded bark acts like an exotic perfume. It's the same with people. It's the rare things that are most highly prized. Once the diameter of the trunk exceeds 4 inches, it's game over. By then, the bark of most species of trees is so thick that it can withstand the impetuous antlered beasts. In addition, the trunks are now so stable that they no longer bend, and they are too wide to fit between the tips of the deer's antlers. But now, the deer need something else. Normally, they wouldn't be living in the forest at all because they eat mostly grass. Grass is a rarity in the natural forest and almost never present in the quantities a whole herd requires, and therefore, these majestic animals prefer to live out in the open. But river valleys, where floods ensure open grassland, are where people like to live. Every square yard is used for urban areas or agriculture, and so the deer have retreated to the forest, even though they sneak out at night. But as typical plant eaters, they need fiber-rich food around the clock. When there isn't anything else, in desperation, they turn to tree bark. When a tree is full of water in the summer, it's easy to peel off its bark. The deer bite into it with their incisors, which they have only on their lower jaw, and pull off whole strips from the bottom up. In winter, when the trees are sleeping and the bark is dry, all the deer can do is tear off chunks. As always, this activity is not only really painful for trees, but also life-threatening. There's often a large-scale fungal invasion through the huge gaping wounds, which quickly breaks down the wood. The damage is so extensive, the tree can't close the wound by quickly walling it off. If the tree grew up in an undisturbed forest, that is to say, nice and slowly, it could survive even severe setbacks like this. Its wood is made up of the tiniest rings, so it's tough and dense, which makes things very difficult for the fungi that are trying to work their way into it. I have often seen tree youngsters like this that have managed to close wounds, even though it took them decades. It's quite another story with the planted trees in our commercial forests. Usually, they grow up very quickly, and their growth rings are huge. Therefore, their wood contains a great deal of air. Air and moisture, these are ideal conditions for fungi. And so, the inevitable happens. Severely damaged trees snap in middle age. If, however, the wounds inflicted over the winter are numerous but small, the tree can close them up without suffering any long-term damage. That's the end of chapter 19. Next time we'll be in chapter 20. Community housing projects.